Hi. Now in this tutorial what I want to do is run through a numerical example on finding stationary points. And just as a very quick reminder, stationary points were points on a curve of the form, say y equals f of x, where the gradient was 0 or the tangents were parallel to the x-axis. And in order to find the x-coordinates of these stationary points, what you had to do was find the gradient at any point on the curve by differentiation and put that gradient dy by dx equal to 0, or possibly f dash x equal to 0 if you're going to use fx notation. Okay, well, let's get on with an example. Now in this example what we've got to do is find the coordinates of the stationary points on the curve y equals x cubed plus 3x squared minus 9x minus 4. And to do this, what we need to do then is first find the gradient at any point on the curve by finding dy by dx. So if we differentiate y with respect to x in the usual way, what we get is 3x squared, and then differentiate the 3x squared and you get plus 6x. Differentiate the minus 9x and you get minus 9. Differentiate minus 4 goes to 0. Okay, now we just need to say therefore at stationary points, then dy by dx equals 0. And if you're doing an exam on something like this, I'd always recommend that you write a statement like that, because that generally will get you a mark. Alright, so we've got a stationary points dy by dx equals 0. So therefore, in our case, 3x squared plus 6x minus 9 would equal 0. And what we've got here is a quadratic equation. Now each term is divisible by 3, so it would pay to divide each term by 3, and that will give us x squared plus 2x minus 3 equals 0. And in the normal way we would try and factorize this or use the quadratic formula to get what x is. Well, this one factorizes. It's a couple of brackets and we have x plus 3 and x minus 1 in them. So we now have two factors, and in the usual way each factor would equal 0. So just write that in. And then for the first equation here, if we subtract 3 from both sides, we get x equals minus 3, and in this one if we add 1 to both sides we get x equals 1. Now we have the x coordinates, and all we need to do now is find the corresponding y coordinates of the stationary points. So we start with when x is minus 3. All we need to do is to substitute x is minus 3 into our equation up here for y to get that corresponding y coordinate. So we have minus 3 cubed plus 3 times minus 3 all squared, minus 9 times minus 3, and then minus 4. And if you work this out either in your head or on a calculator, you should find you get 23. So we already have one stationary point at minus 3, 23. We need to do the same when x is this other coordinate here, 1. And if you substitute that in to here, what you'll find you get is that y turns out to be minus 9. So you need to summarize by saying therefore stationary points. Okay, don't leave it just out there on a limb. Okay, stationary points at, and those stationary points are at minus 3, 23, okay, and at 1, minus 9. So that's our stationary points then. Now the question's not asking us to sketch the graph, but what I'd like to do is just show you what is basically going on in this question. because it's a cubic equation, a plus cubic equation, and so really we should have some idea of what the sketch should look like. So we've got a stationary point at -3, 23. So if I imagine 3 units to the left, 23 units up, let's just say we're up here, say, okay? That's the point -3, 23. The point 1, -9, 1 across, say, 9 units down, let's just say it's about there, 1, -9. It's also a good idea to check where the graph crosses the y-axis, and you can easily get that when x is 0. If you substitute x is 0 in here, you get -4, -4. So y equals -4, let's say that's a point, say, about there. Okay, now a plus cubic curve is going to come up like this. This is a stationary point, so it's going to turn at this point. This is a maximum, and then it comes down through the y-axis at -4, turns at this stationary point, 1, -9, and back up again. Alright, so that's what the graph would look like. We have a maximum point here and a minimum point here. Now you're not always going to be able to sketch the graph that you're given, because it might be just too complicated, or you just might not know what it looks like. So how are you going to know whether you've got a maximum stationary point or a minimum stationary point or even a point of inflection? Well, that's going to be the purpose of my next tutorial, and that is showing you how to distinguish the nature of the stationary point. So I hope you'll have a look at that, but at the moment hopefully this will give you an idea of how we go about calculating the stationary points.